Good afternoon, folks. Welcome to the second stream of our doing some math and related subjects, math, physics, and all those wonderful things here. So today we're going to be talking about particularly some differential equations work, various different subjects. We're going to be going through that, and we're going to have a good old little time. So, blank screen. Let me see. I just managed to lose my... No. Okay. So, we are going to talk about a couple of concepts here. So, let's talk about Schrodinger's equation. So, there's two forms of the Schrodinger's equation. That's going to be the time-independent Schrodinger's equation and the time-dependent model. We are, I believe, working with a time-independent Schrodinger equation. So we're going to start with a Schrodinger's equation for a particle in a box. And this is going to be given by negative h... I'm going to make this a bit thinner. Just one little bit thinner. Where's my thickness? Ooh, that's better. Okay. So negative h bar squared over 2 times m. That's del squared. That's or not del, nabla squared. Psi equals e psi. So psi is essentially a probability function. So it's a form of when you have, say, an expectation value and something around that, you're going to have some kind of psi, which is a function that shows you what that's going to look like. And in 2 dimensions, if you have like an infinite square well like this, it's going to look something like that as the probability, where that's psi, and then this is some maybe x, so psi of x and x, and then this is your, that's the distribution of the probability of where a particle is going to be. And here, that little dot that I'm drawing right now, that is the center of that. That's what we call the expectation value, if I'm describing this correctly. So what we're doing right now is we're going to break this equation down into its constituent components, because we're in x, y, and z. Why is my phone blowing up? Fun. So, first things first, we want to separate this into its Cartesian coordinates. So, start off with what del squared psi is. So, we know that I keep saying del, nabla squared psi equals e times psi times this constant. So we can say negative h bar squared over 2m, open parentheses, and then what nabla is we do the partial x plus partial y plus partial z, because it's nabla squared. It's partial squared x plus partial squared y plus partial squared z of whatever, in this case, psi. So we're going to say partial squared psi partial x squared plus partial squared y, partial y squared plus partial squared z over partial z squared, close parentheses. And all this is being multiplied by that constant there, equals e times psi itself. So now that we've done that, we want to set it into the form, and I'm going to do this in yellow, even though it's kind of a crazy looking yellow. Psi of x, y, z equals psi sub x, which is a shorthand form of partial, of the partial here. X partial y, partial z, z. So that's the form we want to get it into eventually. So now this is an assumption that we're making of a solution. So what we're going to start with here is we're going to say, okay, now my goal now, and keeping in mind as we're doing this, I'm learning as I go. I'm just re-going over. So I don't like have a solution in that I'm just looking over. We're solving this together as a group. So basically, my immediate thought is I want to understand, maybe set everything equal. So if we were to divide by e, we get like psi equals some big constant, where we can say our constant equals negative h bar squared over 2m. And what we can do is divide by e on both sides. So we can multiply e here. And we can get psi equals c partial squared psi partial x squared plus partial squared y partial y squared plus partial squared z partial z squared. And that is, well, it's a differential equation. And the nice thing we can say about this is we can break it up into a one-dimensional form. So that's of x, y, z, right? But we can say, we'll switch to red now. Is this a crazy red? That's fine. X equals c times partial squared psi partial x squared. And the reason that this is the case is because essentially when you do the partial, everything that is not x, y, and z, they're treated as constants, so they go away. And so when I am only expressing the x, y, or z components of this stuff, what we're doing is essentially saying, oh, well, who cares about the y and z components? We can just add them back together. So point being, we can now simply solve this this differential equation that's a lot easier to solve. Because really, this is just the same as equals c psi double prime with respect to x. And this is pretty straightforward. We can just guess a equation that functionally acts this way. There's a couple. One of them is e to the x. Or e to the mx. So if we were to say that we guess, we could use the principle of superposition. So we're going to use orange again. So guess psi of x equals e to the mx. Then we can say that psi double prime of x, we do it once, that m gets kicked out into the bottom, and then we do it again, so it's equals m squared e to the mx. Oh, look! M squared is a constant. And if we say that m squared is equal to c, we can say that the square root of c is m. So what we can say here, I'm gonna make this little aside here. M squared equals c. The square root of c equals m. Therefore, we can go back in here and substitute back out. We're gonna go back to red here. So we can say that we're gonna substitute in. So e to the mx equals c times m squared e to the mx, and we can get rid of this, divide that out. 1 equals cm squared, divide that out, 1 over c equals m squared. So this would be, am I doing something wrong here? Am I doing something weird? Let's see if I'm doing something weird here. So, I mean, yeah, that would be, so then, wait a second. So c equals m to the negative 2. I mean, then that just means e to the mx equals e to the mx if we were to plug that back in, which is true. So, I mean, that works as a solution. So now that we've done that, we can say, okay, c equals m to the negative 2. And we now know that y double prime of x, or partial squared psi partial x squared, is equal to this thing here. Now we know, we've tested it out, that's true. Okay, cool. Guess what we have to do to the other two equations? We just have to do the exact same thing. Now, here's another relation we have to make. Because we know that the square root of c is m, we make the entire function, because we also know that c equals negative h bar squared over 2m e. That means that m equals the square root of negative h bar squared 2m e. Now what's interesting is this gets us into an imaginary value. Let me just double check that's negative. Yeah, that's negative. So that means that the square root of h bar squared 2m e I. Ooh, we can use what's it called? So now we have something that's in the imaginary. So now we can use Euler's formula to convert this into a one-dimensional form. Yeah, I just saw that. Sorry, Din Viagram, my greatest warrior in chat there. So yeah, I think that the answer now is going to be going ahead and converting that form over. So let's go ahead and go back and let's plug this back into our original equation. So the answer to this is, so I don't like this red. I wish it was a little lighter. All right, psi x equals the square, no. Equals negative h bar squared over 2m times e to the square root of this whole thing xi. All right, now we've done that. So I'm going to, I believe if I'm remembering that formula right, it's e to the xi or ix equals e to the x cosine, it's mxi, right? Of mx plus sine of mx. I'm going to double check that. We're going to double check that. So Euler's identity formula. We on that dual wheeled action with the laptop and the desktop today. Let's see. E to the ix. Oh. Okay. Get me into a non-complex form. Come on. Where's that? Where is that? I love Wikipedia, but like the problem with Wikipedia is that it's not something that is, it's very overly complex with the way that it shows off math. I wish there was a better way that they did it. And I get why they do it the way they do it. Oh, come on. I could have sworn there was a better way. Differential equations. Because there's a specific form of it that it uses. Because really, it's e to the ix equals cosine of x plus I sine of x. Now that's the problem here. That's great. It's still complex. So what we're trying to do is get it out of that complex plane into something we can just express in real terms. Come on. Okay, I found it. I mean, I found the Cauchy-Euler version, but it... Let's see. I mean, Cauchy-Euler's fine. We're not in Cauchy-Euler. We're doing a regular, ordinary differential equation here. I mean, okay. A Cauchy-Euler is regular, but I'm talking about, like, you know, we're using e to the mx rather than x to the m, x to the something, which is what you would typically be working with if you're working in that space. If you get imaginary roots, what does it do? Come on, let's do this. We need some music. Why don't I have music running? I thought I had music running. Could have sworn that I had music running in the background. Oh, we got that background music action going. What's going on? Ah! I don't know why I wasn't thinking of that, but now we have background music. Okay. I want to find better music. This is music by Yan something. I have the credit in the description of the stream. Let's see. The other thing is, like, I just don't like using basic sounding music either. We can find something. Let's just get rid of the Euler's identity. Give me a second, folks. We're just hunting for a identity. Found it. Okay. It is. It is. Because, okay, so it's just that basic formula here. So this is in fact the correct one. But what is it? What do we do to get out of imaginary? I always forget. Because usually... Are they deriving it? Okay. No, it is. It is. No. It is. It comes out as y equals, and this is just generally not for our specific case, but it's e to the negative, or no. E to the, we're going to say a for our constant right now, t, c1 cosine of t plus c2 sine of t. That's the general form for that equation. So what we can now do is go back around and say, it's just me, or is The background music jumped. Maybe it's doing a weird turnaround. I dropped 86 frames in the stream so far? That's not good. I'm trying to figure out how to drop less frames. I'm streaming right now at 8 megabits per second. I was streaming, last time I streamed at HEV-C, H.265 to save on bandwidth. I'm trying a bit of a higher bitrate at H.264 to see if that helps us out a little bit with stability, because H.264 is a more mature format, but I want to save as much bandwidth as possible, if I can. H.265 or HEV-C is a much more efficient codec. You're going to add another. Okay. So let's keep going. Let's simplify this back out. We're going to go to like... Ugh, that's a crazy green. I think you can do your own custom formats of color, and I want to improve the colors on this. So let's just say that psi of x equals negative h bar squared over 2m e to the square root of h bar squared over 2m e. I am mushing this together. X I. Now, all we're doing with the y and the z is changing it. We're going to do an uggo color as well. Because it's the same thing. We'll figure this imaginary nonsense out in a second. Hold on. Let's get this. H squared over 2m e to the square root h bar squared 2m e. It's slightly more readable. Y I. And then what are we going to do for it? We'll just do yellow, because my gosh, color theory came here to die. Not y. Psi of z equals negative h bar squared over 2m e to the bar squared over 2m e z I. Okay, so now we've got these three components. It's vaguely Mardi Gras colored, but worse. Like a proper purple that would be a little nicer. Maybe we'll do like a little midstream break at some point and fix these colors. But I digress. So that's the first thing. The second thing is we want to go back to that original form that we had. We'll go to orange. So we're going to say psi equals negative h bar over h bar. By the way, that is the Planck constant. Planck constant is this really tiny number. That's where we're getting that from. H bar over 2m e times we're gonna literally, I'm gonna copy paste. We're gonna copy paste. Boop. Control C. Control V. Move this thing here. Right. Plus. No, don't make it orange. It's cool when it's multicolored. I'm also gonna move this whole thing down because I don't think I have enough room. All right, there we go. Plus this thing plus this thing so that's the form we're in now. Now what we could theoretically do is we could get rid of these imaginary components by saying, number one, that now we can also, so that's the form we're in now. Okay. And now that we've kind of got that going, that's a good beat right there. There's some good little background beats in here. I'm gonna push my levels just like a hair. 25. I don't I don't know a good level to set music to. Some people go as low as negative 60 decibels. I'm sitting at negative 25. I was at negative 30. I like to sit a little higher because my voice right now is running through a compressor and a limiter, so I'm tacked at about negative 3, negative 2 dB, almost hitting 0. I'd like to have hardware compression and hardware amplification because that tends... I believe because you're using... It can allow you to do more because of how the signal's being processed, because you digitize it and all that. I won't get into all that stuff for now. There's a lot of differential equations that goes into audio processing. Convolution's a fun one. Okay, so this now has essentially been put into a form we can start figuring out. Oh, and it's... we need to set initial conditions. And here's my concern. No, we did something dumb. I think we did something dumb, Beer. So that constant we talked about earlier. Now that constant, we need constants that are unknown because we have to set some boundaries. Because, okay, let's talk about what we're actually doing here. Now that we've kind of set this whole thing up, I'm gonna paint you a picture. So we have a three-dimensional little space here. Let's do, I love this feature. You know what we're actually gonna do? We're gonna use features because I can. All right, so we have like a little space here. And inside this little space, this little 3D guy, we have an X coordinate. How do we color our X, Y, and Z? Green, magenta, and so X. Oh, we're still in dotted. X. We have Y. I think actually Y is this way. Although I'm going to just do Y. And we have Z. Okay. So physical space. Now within that physical space, we have a little tiny, we're going to do this in gray to show you what's going on here. All right, and then we go from here to here, and this is not going to be exact because I'm trying to draw parallel lines. No, let's just do this. And then we're going to draw a parallel line from here to here. Always use your guideposts, folks, when you're drawing. One of the things that I've always found is a weird pet peeve about being a physics guy, or just in STEM in general, is people can't draw. And I'm not bad at it, but I'm not amazing at it, and I want to get better at it. I just refuse to go quietly into that night, you know? Let's just make sure that's roughly parallel to that. And we're going to fix this here in a bit. Okay, that's roughly correct. Now, there was a purpose to this. What's the purpose? So, we're going to erase. Boop. Oh, shoot. This is like Mario Kart music almost. This is very like, got a lot of energy to it. So we got this little coordinate system. There's a little wave guy, right? Nope. A little wave, you know? And there's a little wave. And there's a little, ooh. And it's a wave with three components. The X part, the Y part, and the Z part. And we want to know this little wave, how is it shaped? How can it be shaped? And there's a couple of criteria that we have to meet for this wave to be allowed to exist in the way that it does a quantum wave. So this would be like light, or it would be a particle that's trapped in a box, which we've trapped the particle in a box. It ain't get out of the box. It's just in the box. It can't have a bunch of energy at the wall. Has to the waveform itself is gonna, if we're gonna do a cutaway, a 2D cutaway, it's gonna look kind of like this. where it's going to look like something like that. And it's got two things going on here. Number one, on each end here, the magnitude of the wave, if we're going to draw a little dotted line here through the center, that's like 0. It's 0. So that means, what does that mean? That psi of x and y and z equals 0. Psi, also, the slope of that line is also 0. It's not going to just be like, you know, you can't have one of these little actions like, if that was our 0 point. It's not going to just slam into something that's at that edge in a way that's it's gonna smoothly kind of phase into that wall in a way that's nice and elegant. Now this is what the experiments show us. This is what the math also confirms here. So that's our second criteria. So that means that psi prime of x equals 0, where the derivative of a function tells you what the slope of the function is at any given point, right? That's going to be true for x, y, and z, since we have a x component of this, a y component of this, and a z component of this. And when you combine them together, you can get really cool shapes with those specific criteria. So we now have an initial value problem in 3 dimensions. So let's start with that first dimension. I'm just playing with x, and I'm just going to copy that over to y and z to save time, because it's the same thing. It's the same, because in our problem, no, I said y of x equals 0. That's the big dumb right there. Y of 0, psi of 0, psi of 0. Okay. Also, psi of a equals psi of a. What does a mean? That's a. That's a. That's a. That's the size of the box from 0 to a. And so now that we've got that going, we got that cooking. We're just going to copy this over, and we're going to do for y and z. And what's nice, I'm just using color here. Actually, this is very grammaticy. Bam. Copy, paste. Bam. Look at the colors right there. You can't see all of it because I'm in the way. Look at the colors right there. All right. I try to keep my face cam out of the way, but you get the point. All right, now that we've got our kind of visualization of what's going on kind of cooking, let's solve for these particular constants. Now, I'm going to rescind something I did back here. This isn't our constant. That c is really important. And the reason that the c is really important is because now that we know what our criteria are for of 0, it has to be 0 at 0, it has to be 0 at a. Now we can use this to scale up and down our function to match what criteria we've just set. So we're going to keep this negative h bar squared over 2me. We're going to add that constant. Now, another thing I kind of want to do. I just don't like that imaginary. That's the thing that's been messing with me this whole time. I mean, we could say the whole thing's negative. But we're going to keep on rolling with what we got right now. We're going to keep rolling with what we got right now. And we're going to see where that goes. So let's go start with our x. So, and this will copy it over for the y and the z. So, psi, not yellow, obnoxious green. psi of x equals c times this, not that, h bar squared over 2me. See, if it was positive, it would make my life so much easier. I'm making an executive decision. And the reason I'm making an executive decision here, we're gonna get rid of this negative here, and we're gonna just note something. What we're noting here is note rescinded x. Why did we rescind, x. Value. That I don't know what to do with right now. That can be pulled out because the negative value, it's transposable. And we could just make it just a constant c. And then we don't have to worry about taking the square root of a negative. Okay. So I feel like it's skipping around. E to the square root of h bar squared over 2me d, not d, x. Okay, so psi prime of x equals c and we're going to do this, h bar squared over 2me to the 3 halves. Why to the 3 halves? Because that's to the 1 power. That's to the 1/2 power. This square root up here is to the 1/2 power. So what's 1 plus 1/2? 3 halves, baby. E to the square root of h bar squared over 2me x. And now we have two systems and two, I mean, here's what's bugging me right now. Why do we need 2 zeros? This is just a 1. Oh, wait, we did something else we got to figure out. Because there's 2 answers here. I did something dumb. The 2 answers, because there's a C1 plus C2 Y2. That's the full answer for this homogeneous second order differential equation. That is going to be a problem. That's going to be a serious problem because now we have a two-dimensional, or sorry, a two, see, that's what we needed, plus C2Y2 prime. I'm confusing with that Y, but fun. Here's what we're gonna do. We haven't fully guessed it right. I may have to go back in and redo this. Let's go back and see what we got going on here. Yeah, because we did y of x equals e to the mx. Or psi of x is e to the mx. Because, well, it's C1, right? Plus C2 x e to the mx. That's what you'd have to do. And the reason that you'd have to do that, I'm confusing with color now, is because that two-dimensional form is gonna be something. I'm gonna take a quick 5 minutes. I'm gonna go grab me something to drink. So we're gonna do like a all right. It's like see, returning. And then we're gonna do a little Ugnug colors. I'm like leaning into the Ugnug colors. This is bad. All right, folks. See you in a second. Peace. Okay, we returned. Come on, background music. There, that's more different. Okay. So, what we have relearned. I forgot to put the cross on the T, dude. So, these colors have been bugging me. What we're gonna do is, I'm gonna try to figure out a way to do this, just as a little aside here, and then we're gonna try to redo this problem a little bit correctly. So let's go F11. Okay, you can see I'm still in the sin that is Windows 10. Hopefully switching to Linux at some point sooner rather than later. Working towards that. Thanks, music, for making it very difficult. Okay, so let's go to tools, pen options, razor options, hours, text font. You can do latex, that's cool. Or at least text. Preferences? This could be system-wide stuff. Let's go away from that. Edit. No. File. Layout. Columns. Toolbars. Pin option. It's got to be more specific options. Come on. Plugin. I would say it's under edit. Here, let's go to a browser and look up how to do this. ++ change color palette. Let's go into here. Oh, tell me it's not a thing you have to change a file for. That would be annoying. That's like a thing that I legitimately find irritating, is sometimes you have to have like palettes that do that. Oh, hey, how's it going? Let's see. We're currently working on fixing a color palette here. I just don't like it, and I'm in the middle of like, okay, let's fix that right quick. See, we have the customized toolbar. You can drag in different colors. Okay. Let's see. Customized toolbar. Default tools. Edit. Flailing a little bit here. See, because you could do like a custom color here, right? And you can just RGB it. Tools. Plugin, customize toolbar. I'll find it. Toolbars. Customize. Toolbar feature is redefined. Would you like to copy to edit? Yes. Oh, lovely. Oh, I see what you mean. That's cool. Okay, that's way better. Okay. Because see, okay. It was a classic problem of like a lot of the answers that I was just quickly glancing at is... Someone's giving me a call. Is... Oh, I know what this is. Alright, I'm actually gonna quickly... Give me a sec. Hey, sorry about that. Hey, this is Benjamin Eunice. Okay, I need to figure out a better way I can just quickly just jump off stream and take something. Okay, let's go back and see if this will do what I want. Let's just double check. So there's colors here. That's white, red, magenta, orange, yellow, blue. These are predefined colors. What I want is to say, hey, I want a custom color. That would be nice. See other plugins that do that? Cycling through color list. Layer actions, toggle grid. Okay, let's keep looking around online. Color tool, okay, color toolbars managed using a text editor to open the toolbar.ini file. That's the problem. File locations and the section corresponding to toolbar configuration. I do not like that you have to edit a config file to do this. That's not good. That is not good at all. Not a huge fan of this cool car picker. It's the classic you know, issue with some free and open source software packages where it's very non-user friendly. I mean, I'm using, like I said, I'm using OBS and that's great. But saying it, Chief, saying it, we gotta get this, we gotta have a graphical utility for this. You say Linux moment. I mean, it's not. It is a piece of FOSS software often used in Linux. I'm still on Michael's software, unfortunately, but be migrating off of that as soon as reasonably possible. But yeah, it's like we just need better user interfaces there. Not a difficult thing to do either. Doing a color picker seems to me to be not a difficult feature to add to a soft piece of software like this. Because look at that. This is like a great little piece of software. It's got a great little website. Maybe we want to have like not a .github.io, but like, hey, this is fine. It's just would be a great idea to improve things. Okay, are there Crowden project? Oh, translations. Okay, we got to go find that INI file. Love that. Okay, well, now we're gonna boot up another piece of FOSS software that I use a lot called Inkscape. Now this one I'm going to use to make the color palette. I'm going to convert to the new color palette, and then once I've done that, we should hopefully have a better looking system, better vibes. What we had before. Okay, let's make a new document here. One of this, like, okay, so for my setup right now, I'm having to look down to do a lot of this stuff. I could also just look up at my OBS to see the same monitor. It's a little bit disorienting. And frankly, ideally, I'd like to switch to a 2-camera setup for at least for math videos, to where I have an overhead looking down at my desk. It could be another webcam like this, and then a face cam that I could double cut between, and do an inset. I think I have 2 webcams. The other one's just worse. But maybe if we have good enough lighting, we could have something that looks pretty nice. Might be worth experimenting around with. I would just have to have a good mount. I could do like the dank pods thing. Okay, let's start doing this. So we're gonna just have a set of. The whole point of this is just to get something that looks nice. And we are going to quickly do the background to make it black. Actually, we're going to do this. What I like to do, this is a pretty common design thing people will do, where we'll say, okay, we're going to have half of the image be black and half of it be white. And all right, right, like that. We're going to send that to the back. You are fully black. And you are fully white. And then down the center, we're going to have colors. Ah! Now we have something that we can make sure it looks good against black and white backgrounds, just depending on what the vibes are going to be for that particular stream. So we're going to just copy paste this a whole bunch of times. Oh yeah, actually, that's not a bad idea. We can see what's going on there. 1 second, we got somebody at the door. Excuse me for a moment. Yeah, I'm back. Hey, y'all. What did I just do? Oh, I gotta switch back to studio mode. I think that's where we were. I don't remember. We're gonna turn the central heater on. So yeah, my house we do. Typically we've got like space heaters running, mostly just because it keeps our electricity bill a lot lower. We're gonna go full blast for a little bit, just because it's cold. We gotta lock in. Roommates asked about that. I'm getting darker. I'm gonna have to turn the studio lights on. And by studio lights, I mean 2 lamps with literal styrofoam cups duct taped to them so that they are somewhat diffused. But we'll worry about that in a moment. Okay, so back to getting this color palette fixed. This shouldn't take us an immense amount of time. So I'm going to screenshot. Can we... I do not like how inconvenient Windows' screenshot system is. All we're doing is this. This is just going to get that palette for us. Copy. And we're going to paste. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 total. Is this spatially efficient? Nope. Is this gonna be what we gonna use? Yep. Black is fine. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then the white is fine. So we're gonna just airdrop the, or do the, yeah. Windows Shift S. Ah! Thank you for that. That was very helpful. Okay, that's very convenient. I appreciate that. That was very good. This is gonna help me speed up. All right, we got this guy. Then we're gonna do the bright green. And then we're gonna, can I move this back a little bit? Just a hair. There we go. And then, what am I looking for again? The deep blue. Some of these colors we're going to change around a little bit. And then gray. The gray may actually be the one we actually keep, because gray is pretty a straightforward color. The red. Now the red, I want to change the red. I really want to change the red. Some of these are like, and that magenta is just so aggressive. Like, it's not, it ain't it, Chief. The orange is pretty unoffensive. Okay, that yellow is very offensive. All right. Whew, that's a color palette from hell. Let's fix this color palette. Okay. So I'm gonna, you know what I'm actually gonna do? I'm gonna do this. We're gonna do, that's the old one. That's the old one. Copy paste. It's the new one. All right. Start with this one. Let me just slightly change it. See, that's like a little more, like, less offensive looking. This one I want to, that one's a little bit more. All we're really doing right now is just changing these colors up to be a little more nice. Maybe even a little purpler. This orange, I'm not going to change it too much. And this one of the tricks with getting a good yellow to look good against white is doing that. So we've tipped it a little bit in the orange direction, so you notice how it actually shows up against the white and against the black. But it's still a pretty intense color. We may pull it a little bit away from the direct. Just a hair. Just a hair. And the main reason that we're doing that is because it helps us to keep more consistent colors. All right, we're turning on the studio lights. Give us a sec. Now I'm orange. Oh, hey. We're gonna fix the camera right quick. Ah, that's much nicer. That's a much nicer color. Look at the white balance. I actually really like that white balance. It's playing really nicely with the cool and the warm interplay right now, because I've got my windows open, so there's a cooler light coming in and then there's the warm light, and it actually doesn't do horrible things to my skin tones. It's not great, but it's not bad. It's not awful. Okay. Let's keep on working on this. So I prefer this already. Now this darker green also needs to be made to be a bit nicer. Ah. See, I want like a with the colors. You don't want it to be like a punch in the face. You want it to be like a sky blue. That's a nice sky blue. Now this is another one that's like, well, maybe we want this to be a little more like, ooh, you know what I mean? Ooh. And I'm also going to rearrange these colors a bit. So I also want to make sure that the, this I really do want it to be straight up purple. I really do want it to be straight up purple. Because like, why? I don't know. Purple's fun. So like you got to make sure you got the Mardi Gras colors going, you know. See that's nicer. You see how those three colors play with each other better? And they play with each other better on the white, and they play with each other better on the black. See, that works. Is it perfect? No, it's not perfect. So let's arrange these from Roy G. Biv. Roy G. Biv. Look at that. That's a nice color palette. Is it perfect? No, it's not perfect. I want to darken the lighter green a little more, the lime green. That we need to fix too. So let's take this lime. Make it a little bit cooler. Ooh. Make this a little bit more of like a foresty green. Look at that. That's nice. That's very nice. Is it perfect? No, it's nice. And we'll let this gray stay hang out. What the gray is about 50-50. Yeah, that's what I thought. Mathematically, it's going to be roughly that. And then we have a little Roy G. Biv hanging out. Look at that. That's a nice color palette. It's a decent color palette. It's going to be significantly better than we have now. So now we're going to go to that INI file. Where it is, I don't know. We're going to find it. We got to go back to the... Oh, goodness me. All right. View toolbars manage. In the text editor, open the toolbar.ini file. Toolbar.ini file. File locations. Program Zerno++. Okay. It's not that bad. Program files. Program files. Okay. Program files Zerno++. I believe it's under share. See, does it give us a location of that INI? Config. It's under config. Okay. Which makes sense. Is it under lib? Nope. Under bin? Nope. Share. It's not under icons, is it? No. Under locale? That's language settings, Poplar? Nope. Zernal PP? Plugins? No. UI? Let's look up config. Config.py. That's not in there. Is it under program files x86? No. Being a brave man, showing all these files on my stream. It's gotta be under share. Poplar, not Poplar. Where is it? Well, we can look up a .ini, right? Share Zernal PP plugins. And we're just gonna look up. Let me just double check. It's toolbar.ini. Oh, there it is, toolbar.ini. So we're gonna go edit with Notepad++. And we're just gonna replace the colors. And I'll rearrange them if I can. Ah, color. There's the colors. Now, what does it want me to do with the colors? Does it want me to, like, set custom ones? That's the real question. Cool file locations, okay. That section corresponds to your toolbar configuration, my toolbar. Each line under this section header defines the tools used in each toolbar. Find the color item to each line. The 6 question marks correspond to a color in RGB hexadecimal format. Replace the hexadecimal numbers with your... Interesting. Oh, you can add a GIMP color palette file too. Interesting. I'll do that later, but we're gonna do it this method because I'm already in deep. All right. So we've got what was our config anyways? We are in toolbars. Toolbar right copy. Okay. Colors, we'll just do that. And then we'll do color 0. So it's what? It's 0x. All right. 0x. And then it's the red one. We're going to start with the red one. And we're going to copy everything but those last 2 F's over. Boom. And then we're going to just go all the way to color 11. Copy that. Get rid of those extra F's. This is not my favorite, but I'm solving this problem once. That's what we're doing. Probably realize I should probably say this as an administrator because I realized I didn't do that, but whatever. Oh, it just hit me. All right, we gotta do, so 0x, FFF, or sorry, 1, 2, 3, 4, 5, 6. That's white. So color 0x 0, 0, 0, 0, 0, 0, and then there's like one in between. Color, and then that's gonna be, I just want to make sure I double check I know what the one in the middle is. It's 80, 80, 80. 0x 80, 80, 80. How come I saved as it may be protective? Okay, wait. No, hold on. If we're doing that, we're going to copy this whole block here. Control copy. Control saved. Okay, yes, do that. Yes. Did it save? Yes, save. We saved it. Yay. Let's restart the program. Yay. Okay, let me save this. The thing. Oh, Control Shift save. It needs to be under. Okay, now I'm going to move into this. Save under Documents. The thing. Save. Cool. We're going to get rid of this, and we're going to reboot it. Toolbars. There's 2 toolbar rights. That's one of them. There are 2 toolbar rights. And neither of them are the right one. So this is one toolbar right. And then, oh gosh, come on. Okay, so we go to View, Toolbars. You have toolbar right and toolbar right. There shouldn't be 2. That palette never changed. That palette didn't change in the least. Floating toolbox, empty toolbar, empty toolbar, yeah. And then toolbar right copy. I don't know what that's from. It could be in like a config file inside of my users directory. This is confusing. This is bad. This is very bad. This should not be this complicated. Yeah, I have toolbar right. Better colors. Let me just double check I didn't do something strange with the... It could be that is still permitted. However, the hex value will be ignored in favor of the next palette color. It will be automatically migrated when the user customizes the respective toolbar configuration. Oh, there's a palette.gpl file. Okay, so it defaults to that now. That's weird. What if this has turned into a completely different stream? I don't want to waste too much of my time doing this. But that's weird. That's very weird. Okay, hold on. All right, our central heating has started. Need to turn on the heater, off my space heater. That is funky. Yeah, it's kind of annoying. Kind of annoying. View toolbars. So now we can see better colors. And we can see how that's not changed anything. So there's like a palette.gpl file that I have to... I hate everything. I hate all this. Oh, I despise this so much. Okay. Well, let's see if we can figure this out. Palettes. Let's go back to that tutorial. GPL file format. Toolbar palette files. In the config folder. Palette.gpl. Okay. That's what I need to be editing. Cool. So now we got to go all the way back. All the way back. C. Program files. Zernal++. Share. There is no palette file. What? Why is there no palette file? Palette. You know, items match your search. In the config folder, which... The config folder is... Oh, app data local. Okay, well, let's just copy that. Should be almost identical. I'm just gonna change the user. Paste. Is that like a is it like a link? Okay, no, it's not. What is it? Okay. There is in fact a palette.gpl. Okay, let's see what's going on here. Okay. That's a little bit better. Okay. So, we're going to do the thing we just did. I'm going to just do a little splitsy here. We got to do RGB. So, custom, we'll call this the math palette. And we're going to say, okay, so we want to start with red. Of course, it's 255.00. No, we don't want that. We want 226. 39, 39. That's a much better color. We want orange to be next. Orange is going to be 2, 3, 4, 1, 2, 5, 1, 6. That yellow. Yellow is 2, 4, 5, 202, 16. The first green, the dark green, is going to be 9, 5, 170, 71. Light green is next. We'll keep the color names for now. Mostly because I just can't be bothered right now. Light green is 99, 215, 137. All right, and it's light blue. Starting in the right spot, 109. 202, 233. Okay, then the regular old blue. 87872219. 8787219. And then magenta is going to be changed its name to purple. Even though maybe you could say maybe it's some kind of violet-ish color, but I would just say purple just for the sake of simplicity. 234 is the blue. Back to the green. That's 92, and then 154. Okay. Now, do we want the black, white, gray on top or the bottom? I'm gonna say. I'm going to say black, white, gray on the bottom. Cool. Let's see how this looks. Let's restart it, discard. Maybe we'll have something. Ah, we have a new palette of colors. Look at that. Oh, so much nicer. Oh, so much nicer. Now, where is my stylus? Whoo, that's pretty. Let's look at the yellow. Yes, we have pretty colors that actually match relatively well. Thank goodness. See, I can actually do like yellow against white where I couldn't do that before. That's good. And the red doesn't look like, you know, actual doo-doo garbage. It's not going to like deep fry your eyes. That's a reasonable color palette. So there you go. That's how you design a custom color palette for GIMP. Not that you asked. Or for GIMP, for Zernal plus. It's a little bit of a nicer color system, and then we can go to the journal, plain, journal, color, black, yeah. And it looks fine against black too. If not even a little bit spicier. And then I can feel better writing my f of x in red and not worry about it being awful. I don't know why I wrote that way, but yeah, it's not that bad. It's not that bad. Okay. Feel significantly better about that now. It was just a little bit of a relief to the senses there. Now we have a configuration that is not going to kill me as like an artist who likes to have high quality enough colors. I also want to quickly... Why did I open my settings dialog up? Studio mode. I'm having to bump my gain up. I think that's relatively good for what we're doing. All right, we're musicless now. We're musicless. This ain't it. Let's. I'm gonna be part of this series is to point out that. Well, okay, now we're back on music because I restarted something else. Part of the point of this series is, we'll just do the other one, but I'm gonna skip a little bit. Part of the point of this series of me doing these live streams is going to be me improving the live streams on stream. I like that, and part of what makes that work is the trial and error of it. So part of that is getting a better color palette. Part of it's going to be making sure that, we can get rid of some of these ugly toolbars. Like, I'd like to have almost like how Khan Academy has it, where it's just the colors. I just want to be locked in and focused. And I mean, I can do things like turn this off and turn this off, and I have almost nothing there, but I like having the palette there. And I really, I'd have to figure out a better way of handling that. I mean, I could just do something pretty jank like that. Turn that off. And that is, look at this. But then if I want to swap colors, I have to come out, swap my color, to green, do that, come back in. So it's a little irritating. So I'm sticking with this for now as an imperfect way of doing it. And I could probably build a configuration of Zernal++ that is much better for live streaming, because I also want to make sure that I have a little room here, like a little special place for me to hang out, that's like a little safe area, because I'm a block stuff that's in that spot, and I could even make myself a little guy. That'd be cute. And then that to me is more apt in terms of like having a system that is responsive to what I'm doing. What I have going on, it is 100% skipping. The background music is skipping around. I absolutely 100% think I could do a better configuration, but I gotta figure out a way to do it right. Maybe even moving my face cam around a little bit would be good, but we're sticking to where it is now for now. So we got going on. I am gonna start this problem again with better colors. I may even do a different problem, and go from there. That's what we're gonna do. Okay. You can undock them. I think there is a system where you can do that. Because what I could do, since I have a dual monitor setup, I could say I could go. The problem is going off screen because I have this pin, right? And this pin acts as my cursor, so I have to stay on the one screen. So I could use my mouse and go off screen to pick other colors that may be worth it. I could also have keyboard shortcuts. Yeah, that was a good point. Let's see. I'm not going to get super distracted here, but plugin manager, color cycle that, cycling through color list, author, enabled default. Okay, let's enable it. Okay. Now, what does color cycle do? Let's look up color cycle plugin. Color cycle plugin.ini is handwriting marking software. Somebody's saying what's going on. Well, let's go back up here. It's not it. Plugins. Notable plugins. Let you cycle through the cars. Okay. That doesn't. By using the same accelerator repeatedly. I don't know what accelerator means in that context. Yeah, that is not telling me enough of how this works. That's not it. Control Shift 1, 2, 3. Control Shift C. Yeah, I don't know. Yeah, I don't know what's going on there. Very strange. Well, yeah, I don't know. Gotta recycle. Restart, you're saying? Oh. That would make sense to reboot the program whenever you... Alright. I'm looking at my other monitor right now. Alt-C. Oh my gosh, just had the tooltip right there. Yep. That makes a ton of sense. Oh my gosh. That was exactly what needed. Wait a minute. It's cycling through not the actual palette. Why is it doing that? Okay, now we got a weird behavior. Why? Yep. Yeah, the problem... I may just have to live with it. Oh well. I'm not going to try to reinvent the wheel tonight. Although I've basically done part of that. Yeah, we're getting close to our second, just a second little break. Although I may not take it for the moment. I may just set the problem up first. All right. Plane. I always have to do these two things, which I shouldn't have to do. Set that all up. Okay. Let's go ahead and actually get this going. We're going to do a Stokes equation here. And we're going to solve for a series solution to a differential equation. This background music is starting to irritate me. You know what we're gonna do? You know what we're gonna do? You know what we're gonna do? Here's what we're gonna do. I'm gonna kick this up to the top. I'm gonna do something basic. I'm not supposed to do basic stuff. I don't want to do basic stuff. I'm going to use Schlatt and Ludd's Musical Emporium, but I'm going to do it properly. Can we download? I don't know if you heard that, but we're just going to download it. Yes, we can. Download. 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 Okay. Don't know if you heard that either. But so we're going to copy that off into a designated music background music folder. Stream. I just need something that works. That's what we need. There is a thing I have to do. Probably should take a break since I'm trying to fix something right now. See, my question is, am I about to cause some problems here? Let's see. Let's see if I'm about to feed any audio into the system again that I don't want to feed in. So there's a source called VLC videos. Oh. Oh shoot, sorry y'all. Can I hear a thing? Okay, that's something. We've repaired the world a little bit, and I now need to credit it. Oh shoot. I could just hope and pray that I don't get copyrighted on this, but whoa, I just jumped up to a lot more. See, I'm wanting to know what the Creative Commons license. It's a Attribution 3.0 imported, meaning I need to attribute to the composer of the piece, to who was Philip Millman. Oh, let's go to. Strange. We're going to go to this. It should be fine. Let's just assume that it's okay for now. And if I get a thing, I'll worry about that later. So after much ado about nothing, we're going to go ahead and get back to it and talk about this guy with a nice higher quality palette. Okay, so we have the equation d squared y over dx squared. I'm skipping this. This is fine. I don't know if I could take this enough seriously. I don't care. Nah. I can't. Ax y equals 0. And now that we've got this set up, this is also called Airy's equation. We want to assume a series solution, which is y of x equals the sum from lambda equals 0. Why are you using lambda as the index? That's weird. That's really weird. That's really weird. Okay. Which is a sub lambda x to the k plus lambda. I don't like that. I really don't like that format. That's weird. That's really weird. I don't know. We'll keep going with it. Ooh. And I mean, we know y prime of x equals the a sub lambda k plus lambda x to the k plus lambda minus 1. Ooh! That's weird. I don't know if it's bugging anybody else, but that's a weird way to do that. And then y double prime of x k plus lambda k plus lambda minus 1 to the k plus lambda. Then we gotta move this. Minus 1. No, not minus 1, minus 2. Oh, yeah, my music is jumping around. Something's wrong. Something's wrong with my thing. It's starting to drop more frames too. So now that we've got that in the pot, so we can say unfortunately, that the sum, I'm being multicolored today. I'm gonna be real multicolored, so we're just gonna copy this. Put this there. Know what that's all about. We'll keep the yellow for now. We'll switch to orange. Plus this first one here equals 0. AX. Oh, it just got bigger. I got more space now. Too wistful. Ah! So we can say that k value, because what we're doing is we're doing method of Frobenius, where we're setting some, you know, some indicial equation to give some allowed values of k, even though it's weird the way it's formatted. Lambda and k. And then we say, okay, I want this x to go in this guy. I'm using the wrong color there. So we're going to just say, and the A2 which means okay, this alpha and that's an alpha. This is not that's an alpha. It's a different value. Why, math? Why? That's so weird. Not math, but this is a weird question. Okay. So we're going to say it's the sum lambda equals 0 to infinity of alpha a different things sub lambda x to the k plus lambda plus 1 because we added the x, so we bump it up by 1. Plus, and I'm going to write this backwards, which is going to feel weird. Well, no, I could just do this because I don't have to do anything with it. So now we have that. And now, it's such a weird song. I'm assuming I can get away with, what am I thinking? This isn't that bad. Oh, so now that we've pulled these k plus lambdas out, we can actually get rid of the k's. So we're going to like use our red to say this goes away and this goes away. Why is we do that? Because we divide it by x to the k. And everything here is canceled. So it's, and the reason that it's canceled, yeah, everything's in terms of x to the k. We can pull the x to the k's out of the sums and then divide by that. That's what I effectively just did. But we got those k plus lambdas and the k plus lambda minus 1, which is going to help us find our indicial equation. And the indicial equation, I'll show you in a sec. Okay. We want to kick all these guys out by first doing a substitution. And then we're going to do the substitution, and then we're going to do the thing. So let's do this one first. So I hate the fact that I can't use my normal k because it's already using k for something else. We're going to do m equals lambda minus 2. So that means lambda equals m plus 2. Now, this infinity lambda equals, or not lambda, we're in m now. M equals -2, right? Because m equals 0 minus 2 minus 2. A to the lambda, not lambda, m plus 2. K plus m plus 2. K plus m plus 1. X to the m. Yeah. Yeah. Plus. Now this one is plus 1. I could have not done the sub like this. I could have gotten it to be equals lambda plus 1, but I'm just going to do the sub here anyway. So we're going to say m equals lambda plus 1. Lambda equals m minus 1. So we could say lambda equals 1 now to infinity. Alpha a m equals lambda plus 1. Lambda equals m minus 1. X to the m equals 0. Now what's nice about this is we can put everything under one fun and goofy little guy. Except we can't. I lied. Why did I lie? Because it's fun to mislead people. So we need these little guys here to be the same, but they're not the same. So we're going to have to add the -2, -1, and 1, and 0 before everything else. What does that mean? Well, that's what the purple parts are going to be. So what's a of -2 plus 2? That's a naught times k minus 2 plus 2. That's k plus 0. K minus 2 plus 1. K minus 1. X to the -2. Plus -1. Or m equals -1. A equals 2 minus 1. So A1 K plus 2 minus 1 K plus 1 times K X to the -1. And then the third one, which is m is 0, plus A2. What the fuck? Oh, I was like really confused as to what that intro was. K plus m plus 2. Okay, this time our m is 0, so K plus 2, and then 0, A, K plus 1, X to the 0, which is 1, so we don't have to even worry about that. Now we add... Actually, let's do it this way. Plus, I'm going to do orange for this. The combinated m equals 1. I actually need to quickly sub that back out because that's technically m. Infinity. A m plus 2. Nope. That's a subscript. M plus 2. K plus m plus 2. K plus m plus 1. X to the m. Not x to the m. We don't have to add that right now. Not yet. Wait. Plus alpha. Alpha. A. Oop. A. That's so hard to distinguish. M minus 1. Now all this stuff inside of here is multiplied by x to the m. And that all equals 0. Now, here's something interesting. You can set all of these individual things equal to 0. And you can also set this thing individually equal to 0. So we can get two things out of this. We can get a recurrence relation, and we can get what are called indicial roots, where k equals some number. So since x to the -2, x to the -1, and then x to the 0 are just 1, we can now set some indicial roots. And in this case, I'm seeing 3. And if you remember from high school or whatever, you can do k times k minus 1. Oh, what are the roots of that? It's 0 and positive 1. To give you your roots. So those are called indicial roots for this system. So we can then assume that k equals 0 or k equals 1. And then we can solve for this part here by setting k equals to 0 or 1 on the bottom here. And then you can have a recurrence relation set up already. So we're going to say for our indicial equation, and we're going to swap to another color here. Just do regular old blue. Blue. So well, that's a T, whoa. Equation. What's the indicial equation? A naught k minus 1 equals 0. Oh! K equals 0 and 1. A1. K plus 1. K equals 0. K equals 0, negative 1. And then A sub 2. K plus 2. K plus 1 equals 0. K equals negative 1, negative 2. So the allowed K values, K equals negative 2, negative 1, 0, and 1. I feel like I'm doing something wrong here. It's the internet. Someone will loudly and aggressively tell me why I'm wrong. Let's quickly do that. I forgot to give myself my little blank space. Whee. There's got to be just a quick control in or something for a new page, but I feel like the new page, it just resets to that like default that I have to change back anyways, so we're going to have to do a bit of that as well. Okay. So that's part of our answer. This dark blue on black is brave. I mean, it's technically showing up and popping, but it's weird looking. Okay. And then we just want to get ourselves a little a recursion. So I'm gonna quickly copy this over to the next page. And we're gonna just do the little eraser bit to the extra stuff, the lanyap. Okay, now this is what we can turn into our indicial equation, or sorry, indicial or recurrence relation, where all this lanyap can be cut out. This can be gone, you know, and we can say that, you know, a m plus 2, k plus m plus 2, k plus m plus 1 plus alpha a m minus 1 equals 0. And then we can simply subtract one from the other, that a m minus 1. So, and then divide by all these things. So we could say a m plus 2 equals negative alpha a m minus 1, all dividing k plus m plus 2, k plus m plus 1. So for any value of k that we plug in, we can then say, okay, do we know at least one value? Do we know a sub 0? Do we know a sub 1? And from that, you can say, you could start to figure out some general thing. I think we've looped around this whole playlist. Yeah, I'm almost certain we've looped around this playlist once now. We need a longer playlist. We need more music. But we've got a problem done. Look at that, guys. Look at this, folks. Bam. Hold on. Yeah. Yeah. Nice. I'm pleased with that. We got something done. It only took us 2 hours and 15 minutes to get one thing done. I guess that's fine. DH. Goodness gracious sakes alive. Okay. Well, now we can move on to the next question. I'm gonna do a new. See, it does that. That's dumb. That's dumb. That's real dumb. All right, I'm going to take a little bit of a break. As we have reached a little thing, I'll just say, whoa. That looks like an A. Actually, no. That's awful. We break in, that's not great, but hey, it is what it is. See you guys in a second. Take a couple minutes and I'll be right back with more thrilling installment of mathematics.